All right, today we're looking at 6-4, which is special systems. And so we've done the substitution, graphing, and elimination method. And so now we're just looking at how to classify some of the systems. Some of them fall into certain categories. There are two types of systems. If you cannot see the board, listen to my voice, look at what I write, or look at the paper in front of you that you picked up off the table that have the notes and kind of fill them in as we go. The first system says consistent system. And a consistent system is basically a system with at least one solution. A consistent system is a system with at least one solution. And an inconsistent system is a system, and I'm sure some of you probably have already guessed it, with no solution. A system with no solution. An example of inconsistent system, of course, no solution we know are parallel lines. Consistent would mean infinitely many solutions, or if it has one solution. So we're going to look at some problems kind of like what we did last week and finished up on yesterday. And we have these two examples, y equals x minus 1 and negative x plus y equals 2. And I'll scroll down a little bit because you can't really see it. About right there. And it says to solve these two systems with no solution two different ways. So when we look at it, we see that it's already a y equals. So the first method I'm going to use, I'm going to do graphing method. So with graphing method, we have to put both equations in y equals. One of them is already in slope-intercept form. The second one, in order to get it in slope-intercept form, we need to add x to both sides. And so then that second equation ends up becoming y equals 2 plus x. And so, I really don't write it that way. I like writing the slope first. So y equals x plus 2. And so when we look at our two equations, we see that they have the same slope. So if you put both of those in your calculator, remember you go to y equals, type it in x minus 1, and in y2 you're typing in x plus 2. And when you graph it, you'll see that they are parallel. So this would be inconsistent system because it has no solution. And a second method of solving the same one is, this one is already in y equals 4. So we can use the substitution method. And wherever we see a y, we can plug in x minus 1. So then we end up with negative x plus x, sorry, wrote that wrong. Negative x plus x minus 1 equals 2. Our x's both cancel out. All we're left with is negative 1 equals 2. And is that a true statement? No, it is not. Negative 1 is not equal to 2. So this would be an answer where it would be no solution. And it is an inconsistent system. Everybody got that? All right. Here's another example. It says choose two methods to solve it. We'll do substitution and elimination method. This first one, let's do elimination. So we have the equation y equals 2x plus 1. And remember, with elimination, we have to put it in standard form. And so we're going to subtract 2x on both sides. And so we have negative 2x plus y equals 1. And I really don't have to worry about my standard form rules right now. You remember a can't be a negative and we can't have any positives. Because since we're actually getting in the standard form so that we can eliminate it, it's okay for me to just leave it right here. I'm not really following the rules. And so there's my first equation. Then on that second equation, if you look at it, it's 2x minus y plus 1 equals 0. And so to get it standard form, I need to move the 1 to the other side. So I'm going to subtract 1 on both sides. And so that one ends up being 2x minus y equals negative 1. And so both of the equations are standard form. So if you remember with the steps, once you get both of them in standard form, we're going to stack them on top of each other. So I'm going to just come up here and scroll up a little bit. Or I'm actually right over here on the side. And so I'm going to stack both of them on top of each other. So I have negative 2x plus y equals 1. And then I have 2x minus y equals negative 1. And what do you notice? Both the x and the y cancels out. And there's nothing left on the left. And 1 minus 0 cancels. 1 minus 1 cancels, and it's just 0 equals 0. And so this is an example of infinitely many solutions. Everybody got that? You need me? I could pause it.